Hydrology is an extremely important field of study dealing with one of the most valuable resources on Earth, water. Water is always on the move. From the time the Earth was formed, it has been endlessly circulating through the hydrologic cycle. Groundwater is an important part of this continuous cycle as water evaporates, forms clouds, and returns to Earth as precipitation. But what is groundwater? Water that has traveled down from the soil surface and collected in the spaces between sediments and the cracks within rock is called groundwater. Groundwater fills in all the empty spaces underground in what is called the saturated zone until it reaches an impenetrable layer of rock. Groundwater is contained and flows through bodies of rock and sediment called aquifers. The amount of time that groundwater remains in aquifers is called its residence time, which can vary wildly from a few days or weeks to 10,000 years or more.
The top of the saturated zone is called the water table, and sitting above the water table is the unsaturated zone, where the spaces in between rocks and sediments are filled with both water and air. Water found in this zone is called soil moisture and is distinct from groundwater. Groundwater plays a crucial role in sustaining stream flow during dry periods and is vital to many lakes and wetlands. In addition to human uses, many plants and aquatic animals depend upon the groundwater.
The hydrologic cycle, or the water cycle, has no starting point, but will begin in the oceans, since that is where most of the Earth's water exists. The sun, which drives the cycle, heats water in the ocean. Some of it evaporates as vapor into the air. Ice and snow can sublimate directly into water vapor. Rising air currents take the vapor up into the atmosphere, along with water from evapotranspiration, which is water transpired from plants and evaporated from the soil. The vapor rises into the air where cooler temperatures causes it to condense into clouds. Air currents move clouds around the globe. Cloud particles collide, grow, and fall out of the sky as precipitation. Some precipitation falls as snow and can accumulate as ice caps and glaciers, which can store frozen water for thousands of years. Snowpacks in warmer climates often thaw and melt when spring arrives, and the melted water flows over land as snow melts.
Some infiltration stays close to the land surface and seep back into surface water bodies and the ocean. As groundwater discharges, and some groundwater finds openings in the land surface and emerges as freshwater springs. Over time, though, all of this water keeps moving, some to enter the ocean, where the water cycle repeats.
So, groundwater is a vital water supply for humanity. Groundwater provides drinking water entirely or in part of as much as 50% of the global population and accounts for 43% of all of water used for irrigation. Worldwide, 2.5 billion people depend solely on groundwater resources to satisfy their basic daily water needs. Globally, groundwater is an essential freshwater resource for both socio-economic and environmental systems, and forms a critical buffer during periods of drought. So, groundwater is a source of recharge for lakes, rivers, and wetlands.
Modern scientific measurements show that many of major aquifers, like groundwater reservoirs of the world, are being depleted. Such depletion can lead to decrease in stream flow, drying of spring or wetlands, loss of vegetation, water level declines in wells, and land subsidence. Yet, another threat to groundwater is pollution resulting from human activity, generating chemicals and waste that have leaked into the subsurface. Pollution degrades the quality of groundwater and poses a threat to human and ecological health. As the human population grows, more demand will be placed on groundwater, a vast but finite resource.
The need for understanding our groundwater systems and for managing them in a thoughtful manner within the constraints of the hydrologic cycle is greater than ever.